Okay. So introduction to foundation design using EC7 part 1. Okay, because we have two parts actually for the EC7, where the first one is on the design foundation and second one is on the soil investigations. So what I'm going to talk about, okay, so concentrate on practical applications, okay, brief review of the traditional design approach, okay, understanding EC7, okay, EC7 Geotechnical Design Part 1, Chapter 7, Pile, okay, so Malaysian National Annex 2012, EC7 Design Method and Partial Factor for Shallow and Deep Foundations. Okay. So if you are familiar with EC7, EC code or Euro code, okay, so it has 10 items here, okay. So for the Euro code EC0, okay, we discuss on the basis of design. Okay, then we have the EC1 action on structure. Okay, EC2 design of concrete structure. EC3 where they discuss on the steel structure. Then we have the EC4 where discuss on the design of composite steel and concrete structure. So for the geotechnical design, okay, we may refer to the EC7. Okay. So actually, this is a guideline to be used. Okay, while there are some elements which is not mandatory to be used. Okay, so it's just a guideline to guide for the engineer. Okay, to design. Okay, to be used in design. Okay, for us as a geotechnical design, so we may use it for the deep or for the foundation design. Then we also have EC8 design of structure for earthquake resistant. And the last one is EC9 design of aluminium alloy structure. Okay, okay, so this is sorry. Okay. So the main item is on the EC0 and EC1. Okay. So then all the related component start from EC3, EC2 to EC6, okay, which is more related to structure components, okay. Then for the geotechnical design and also of the and for the design of structure for earthquake resistant, it actually is encapsulate, okay, for all these main elements, okay. So means that for geotechnical designs, it cover for all the design structure for concrete, steel, composite, timber, masonry, and also for the aluminiums. So the objective of the Euro codes as a mean to prove compliance of building and civil engineering works with the essential requirement of mechanical resistance and stability and safety in case of fire. Okay, so that is the one of the objective of the EC. A basis for specifying contracts for construction works and related engineering service. Okay, and then a framework for drawing up harmonized technical specs for construction products. Okay, so previously, by using the conventional way, okay, so we already specify what we call as the factor of safety. For example, we normally use the factor safety for pile design or for shallow foundation design up to 3. Okay, but by using this EC7, okay, so when we do the calculation, okay, at the end we may identify what will be the factor safety, okay, by comparing or by having a ratio between the action load and also the design load. Okay, so then we may obtain the factor safety. Okay, So means that if the factor safety is greater than 1, okay, so it has already complied with the EC7. Okay, so we may discuss later, okay, in terms of how to gain or how to calculate for the factor safety by using this EC7. Okay. So improve the functioning of a single market for products engineering service by removing obstacles arising from different nationality codified practice for the assessment of structural liabilities. Okay. Improve the competitiveness of the European construction industry and its professional industry in country outside the European Union. Okay. So due to the British or UK previously is the member of the EU, okay. So then we just follow the UK, okay, where previously they use the British standard, okay. Then when they join the EU, so they follow the EU regulation where they follow the EC practice, okay. So then Malaysia just follow the EC, which is from previously from British standard to the Euro codes. Okay. So EC design method or the Euro codes are all based on a common design methods. The common design method is presented in EC 1990. Okay. A common loading codes for all European is presented in 1991. Okay, which is the EEC1 actions. Okay. The Eurocode share a common terminology and symbol. Okay. So we still use the theory, for example, for the shallow foundation, we still follow the Meyerhoff and also the Terzaghi. Okay. And also we still use the what we call is the formula for the deep foundation, which is we need to identify what is the frictions and also the end bearing. Okay. However, we just include some new symbol and new factor, okay, in getting the factor of safety of the problems. Okay. So the common design methods for the verification of safety and serviceability involves the limit state design methods, okay, partial factors, characteristic action and material parameter or resistance, and reliability base. Okay. So from there we can reduce the uncertainty. Okay. So we still rely on the limit state design method where we want to get what is the ultimate limit state value. Okay. So then we apply for the partial factor. Okay. Previously we call it as a safety factor. So now they call it as a partial factors. Okay. In the calculations. Okay. So there will be a characteristic on the actions, okay, and also on the material. Okay, so we need to know what is the factor that we should use, okay, to calculate for the action and also the material parameter. Okay. So then it is based on the reliability base. Okay. For example, when we want to calculate for the deep foundations, okay, where for example, if we carry out for several pilot tests, okay, so we may use the reliability approach, okay, to identify what is the fact, what will be the design loads for the pile. Okay. So comparison between EC and BS, the construction industry has traditionally used British standard as a benchmark for what is considered good industry practice. Okay, it has, however, been reported that only 29% of civil engineering organizations are prepared for the introductions of the codes suggests that the industry is not prepared for the arrival of the goods. Okay, so I'm not sure. 29% uh, in this slide is again from which years? Okay, because this is a slide prepared by Prof. Ramli. Okay, so hopefully it's already been increased. Okay, because the government want to implement the EC in the design or in the submissions. Okay, I still remember when I have interviewed for my PE, okay, professional engineer, in 2020. Okay. So I have prepared the report based on the EC7, okay, for the retaining structure. Okay. So surprisingly, the examiner say that we are not still use it 100% for the EC7s. Okay. So and I guess now we are getting better. Okay, so we are moving to use this EC7, okay, in the design, in the submission. Okay. So it's important to recognize that from now on they will dictate that required standard of for most public projects. Okay, so this is the what they are moving now. Okay, to implement of this EC7. Over time, the replaced British standard will become out of date and will probably be eclipsed by the Euro codes. Okay. So with regard to defect disputes, issues often include whether or not works have been completed to the industry standard. In this case, it is likely that the Euro code will become the benchmark. Okay. The Eurocode are limit state code like the British standard, although are perhaps a little more explicitly based on reliability theory. Okay. The Eurocode are also less prescriptive than the British standard, with more aspects left open to the designer. Okay, so it is rely on the designer experience, okay, judgment, okay, that could be included in the design stage by using the Euro codes. Okay, so this is a little bit difference or the advantage, okay, of using the conventional design and Euro codes. Okay, so conventional design use global factor safety and simple applications. Okay, as customs to use, okay, because we are familiar with the conventional design. Okay, so that's why it is we are prefer to use the conventional way because it's simple and then straightforward. Okay, so for the Euro codes using the partial factor of safety and harmonic design. Okay, where at the end we want to identify what is the factor of safety. Okay? So the type of the load has different level of uncertainties. Okay, so we may have a different type of approach. For example, favorable, unfavorable. Okay, in terms of the load that we may use. Okay, uniform level of safety. Okay, so it is more it introduce this kind of level of safety in the design. Okay, so it also have a risk assessment as well. Okay, so the disadvantage inadequate amount of variability. Okay, stress is not a good measure of resistance. Factor safety is subjective. Okay, no risk assessment. Okay, however, for the Euro codes, it's more complex. All habits requires ability of statistical data. Resistance factor varies. Okay, so I just want to mention here the Eurocode is, for me, is very more complex compared to the conventional design or British standard. Okay, EN 1990 describe the principle and requirement for safety, serviceability, and durability of structure. So it is based on the limit state concept used in conjunction with a partial factor methods. For the design of a new structure, EN 1990 is intended to be used for direct application together with Eurocode 1991 to 1999. Okay. So if you want to get a better understanding on the action on the okay, on the basis of design, okay, so you need to look on the EN 1990 first, okay, and then you can get a better understanding on the basis of design, and it can be used together with Eurocode from 1991 to 1999. So Eurocode 1999 also give guideline for the aspect of structurability relating for safety, serviceability, and durability. Okay. For design cases not covered by EN 1990 to EN 1999, okay, other action structure not treated other material. Okay, to serve as a reference document for other uh, CEN, okay, European Committee for Standardization, etc. concerning structure matters. So EN 1990 is intended for use by committee drafting standard for structure design and related product testing and execution standards, clients, designer and constructions, and relevant authorities. Okay. So this is just introduction on EN 1990. Okay. So EN 1990 may be used when relevant as a guidance document for the design of structure outside the scope of Europeans 1991 to 1999. Okay. For assessing other action and their combinations, modeling material and structure behavior, assessing numerical value of the reliability formats. Okay. So this standard gives alternative procedure, value, and recommendation for classes with notes indicating where national choice may have to be made. Okay. So therefore, the national standard implementing EN 1990 should have a national annex containing all nationality determines parameter to be used for the design of building and civil engineering works to be constructed in the relevant country. Okay. So means that that's why the Malaysia standard, okay, has been proposed, okay, based on this sentence or this statement in the Euro Code 1990, where they provide a statement that any country can come up with their own recommendations. Okay. So if we go through on the EN 1990, okay, so this is the section that discuss on where any country, okay, have their own choice, okay, to come up with their own standard, okay. As I told you previously that Malaysia has produced the Malaysian standard, okay, which is discussed, for example, on the pits problems, okay, in the Malaysian standard, and also there are some difference in terms of the coefficients that that's been used in the design. Okay. So the general assumption of EN 1990 are the choice of the structure system and the design of structure is made by appropriately qualified and experienced personnel. Okay. Executions is carried out by personnel having the appropriate skill and experience. Okay. So that is the uh, like the common uh, rules that need to be followed by the by 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 the designer, okay, or by the contractor, okay. So adequate supervision and quality control is provided during executions of the work, okay, in office design, factories, plant, and on site. Okay. So the construction material and products are used as specified in EN 1990 or EN 1991 to EN 1999 or in the relevant execution standard or reference material or product specification. Okay. The structure will be adequately maintained. Okay. The structure will be used in accordance with the design assumptions. Okay. So these statements, okay, provide a freedom, okay, for the designer, okay, in terms of how to design, okay, based on the complexity of the structure, okay. So for example, if you want to build a resident area, okay, so we should have a very good soil investigations result, okay, and then we may yeah, for example, if the structure is more bigger, so we need to have a pilot test as well. Yeah, however, if we want to design for a guard house, okay, so it's not compulsory to have for example a thorough soil investigation testing. It is enough to have, for example, a Macintosh probe, okay, to get an idea what will be the bearing capacity of the soil. Okay, so that is the advantage of what has been stated in the EN 1990. Okay. So terms used principle are mandatory. Okay, which has been stated in the standard, okay, normative requirement. Okay, principal clauses in the code are identified by a P after the clause number and contain the word shall. Okay, so we share the MS standard. So in the MS standard also have these terms, okay, which is normative, okay, which is the principle, okay, uh, and also have what we call as an informative. Okay, so informative uh, is not compulsory to be used. Okay, all other clause are application rules that indicate the manner in which the design may be shown to comply with the principle. Okay, application rules are informative, okay, not mandatory and for information only, and use words such as should and may. Okay. Okay. So that is for the EN 1990. Okay. And then when we relate to EN 1997, which is discussed on the geotechnical design. Okay. So we have here part 1 and also part 2 in the EN 1997. However, okay, I guess for Malaysia part, uh, the part 2 has not been published yet. Okay, so we already have part 1 only at the moment. Okay, so it's already been published in 2012. Okay, so the for Eurocode 7 consists of two parts. Okay, geotechnical design, general rules, and ground investigation and testing for the part 2. Okay, so it is important to appreciate that EN 1997 Part 1 is not a detailed geotechnical design manual, but it is intended to provide a framework for design and for checking that a design will perform satisfactorily, that is, the structure will not reach a limiting condition in prescribed design situations. Okay. So for the part 2, okay, under the geotechnical ground investigation and testing, okay, for Malaysian case, okay, so if, for example, if we refer to the part 2, okay, most of the ground investigation work, okay, they have suggested to use the rotary drilling, okay. However, in Malaysia, we still use the wash drilling, okay, during the soil investigation work, okay. So because they are not very common to use the rotary drilling, okay, in Malaysia, and most of the contractor, okay, still using the wash drilling, okay. So that's why there's still a debate, okay, in order to produce for the part 2, okay. Because if 100% follow the part 2 based on the Euro Code 1997, okay, so not there will be a problems in the ground investigation industry, okay, because most of the contractor have a problem to apply or to use the rotary drilling because it's very expensive. Okay, okay, this is what I have heard from Prof. Ramli. Okay. Okay, the code therefore provides in outline all the general requirement for conducting and checking design. Okay, so it provides only limited assistance or information on how to perform design calculation, and further detail may be required from other texts such as standard soil mechanics books and industry publications. Okay, so when I refer to the MS 1997, okay, sorry, and it's only have 21 pages, okay, so it's not very thick, okay, so it's difficult to understand, okay, by only rely on this standard, okay, so that's why I provide to you the reference book, okay, where we can understand more deeply, okay, on how to design by using the EN 97. Okay, so part 2 covers ground investigation and testing. Okay, however, we doesn't, yeah, as mentioned, we Malaysian has not have yet the part 2. Okay, so the applications of the code in Malaysia require reference to the Malaysian National Annex, which provide the partial factor prescribed for use in the Malaysia. Okay, so the Malaysian National Annex for Part 1 will be available. Okay, it's already available in 2012, and the National Index for Part 2 is expected to be published after that, since it is still in progress. Okay. However, still in 2022, okay, Part 2 has not been published yet. Based on my discussion with Prof. Ramli, okay, because Prof. Ramli is the part of the committee for the MS Part 1. Okay, his name is yeah, he is the member of technical committee on geotechnical works. Okay, so he represent UTM, and the other lecturer represent UITM is Associate Professor Dr. Muhammad Jamaluddin Matno. Okay, so only two academicians uh, is is in the member of technical committee. Okay, so that's why I can see that the part 2 has not been has not been published yet, because the Ramli is one of the technical committee. it also to prepare for the part 2. Okay. So a series of geotechnical execution standard covering geotechnical processes such as piling works and grouting also exist. These are primarily of interest to construction, but also of general interest to designer. Okay. Okay, it's prescribed the general principle and application rules for the technical design, primarily to ensure safety, okay, which is adequate strength and stability, serviceability, acceptable movement and deformations, and durability of supported structure that is of building and civil engineering works founded on soil or rock. Okay. As I've mentioned previously, principles are mandatory, okay, requirement. So principal clause in the codes are ratified by a P after the clause number and contain the word shall. So all other clause are application rules that indicate the manner in which the design may be shown to comply with the principle. Application rules are informative, not mandatory, and for information only, and use words such as should and may. Okay, so now we look on the content of EC7 1990, EN 1997, part 1. Okay, contains the following section, okay, which is the general, okay, section 1. Then they have a section 2, basics of geotechnical design. Then they have a section 3, geotechnical data. Section 4, supervisions of construction, okay, monitoring and maintenance. Section 5, field dewatering, ground improvement and reinforcement. Okay. Then section 6, split foundations. 7, pile foundation. 8, anchorage, okay, still not apply in Malaysia, okay. So then we have there section 9, retaining structure. 10, hydraulic failure. 11, site stability, and the last one is the embankment. Okay, so that is what has been the content in the EN 1997 part 1. So the annex is informative, which means that the partial factor listed must be used. Okay. So however, the value of this factor are a matter for national determination, and the value shown in the annex are those only recommended. Okay. So Annex A is used with section 6 to 12 as it gives the relevant partial and correlation factor and their recommended value for ultimate limit state design. Okay. So actually I didn't have the EC7 1997, EC 97. Okay. So I could not share the soft copy of this EC 97. Okay. However, if I get the copy, so I will upload in the e-learning letter. Okay. Okay, because it's very different between the MS 97. MS 97 is very general, okay, compared to the what I have listed in this slide. Okay, and Annex A is normative, which means that it is an integral part of the standard, and the factor in must be used, although the value are informative and may therefore be modified in the national annex. So Annex B give some background information on the 3 alternative design approach permitted by EN 1990 and given in EN 1997. Okay, so this is just an introduction on what is the content of the EN 97. Okay. So Annex C, H, Annex C to G provide example of internationally recognized calculation method for design of foundation or retaining structures. Okay. And then Annex C to J are informative, which means that in principle they may be superseded in the national annex. Okay, so this is the table content, okay, for the annex. Okay, so we have here annex A to J, okay, and the status of the annex, okay, from normative to informative, okay, and that's the title provided for each annex, okay. So design philosophy in EN 1997, okay, and understanding of limit state design can be obtained by contrasting it with working state design. Okay, working state design analyze the expected working state, then apply margin of safety, and then we have the limit state design analyze the unexpected states at which the structure has reached an unacceptable limits. Okay, then make sure that the limit state are unrealistic or at least unlikely. Okay. So that is the design and design philosophy in Eurocode 1997. So uh, it's a limit state design code, which means that a design that complies with it will prevent the occurrence of a limit state. Okay, a limit state could, for example, be an unsafe situation. Okay, so damage to the structure and economic loss. Okay. So while there are in the theory many limit state that can be envisaged, okay, it has been found convenient to identify two fundamentally different type of limit state, each of them having its own design requirement. Okay, so we have here ultimate limit state and also serviceability limit state. Okay, so ultimate limit state, okay, it is more on the safety issue. Okay, while serviceability limit state is more on the deformations and also on comfortable. Okay, for example, if the building have so many crack, so uh, what we call uh, the people who stay inside will not uh, comfort. Okay, with that situations. Okay. Okay. So ULS are defined as a state associated with collapse or with other similar forms of structure failure. Okay, for example, failure of the foundation due to insufficient bearing resistance. Okay, in geotechnical design, ULS include failure by excessive deformation, loss of stability of structure, or any part of it. Okay, hence a state in which part of the structure becomes unsafe because of foundation settlement or other ground movement should be regarded as a ULS even if the ground itself has not reached the limit of its strength. Okay, so if the ground movement is very huge, so can be considered under the ultimate limit state. Okay. So ULS or full collapse or failure of the technical structure are fortunately quite rare. Okay. However, an ultimate state may develop in the supported structure because of large displacement of foundation, which has itself not failed. Okay. This means, for example, that a foundation may be stable after initially settling. Okay, it's not exceeded a ULS or fail, but part of the supported structure may have failed. For example, a beam has lost its bearing and collapsed owing to substantial deformation in the structure. Okay, what is the general approach to design? Okay, the principal emphasis of Eurocode 7, it is the definition application of partially factor of safety. A factor are applied to characteristic action. Okay, so later on we may look on this factor. Okay, so we have a characteristic factor, nominal dimension, and the last one is characteristic material properties. Okay, so we have three type of factor. Okay, in the Eurocode 7. They are considered through calculation with a view to ensuring that the design effects are less than or equal to the design resistance. Okay, where relevant, the codes requires a total of 5 different ultimate state to be considered. Okay, so in here we have 5 different ultimate state. Okay, however, in geotechnical design, so we may not use all these 5. Okay, so normally we may only use for under the geotechnic. Okay, or we may use under the equilibriums. Okay, for example, for any overturning structure. Okay, like what we call as retaining structure, so we may use the equilibrium uh, for the limit state that we will consider. So this is the 5 uh, limit ultimate limit state ultimate state. Okay, that we may consider in the design. Okay, the first one is the equilibrium. The loss of equilibrium of the structure of the ground. Consider a rigid body in which the strength of the structure, material, and the ground are insignificant in providing resistance. Okay. Then the second one is STR, internal failure of excessive deformation of the structure or structural elements, including footing, pile, basement, wall, in which the strength of the structure material is significant in providing resistance. Okay. Geo failure or excessive information of the ground in which the strength of the soil or rock is significant in providing resistance. For example, overall stability, bearing resistance or split foundation or pile foundation. UPL, loss of equilibrium of the structure or the ground due to uplift by water pressure, okay, buoyancy or other vertical action. And the last one is the HYD, okay, hydraulic heave, internal erosion and piping in the ground caused by hydraulic gradients. Okay, so we may not use all, okay, for the example, especially on the shallow and deep foundations. Okay, but this is 5 types of limit state that has been included in the EN7. So this is the diagram, okay, show that the type of the ultimate limit state, okay, the STR based on the structure, the geo based on the failure of the ground, okay, and then the EQU based on loss of static equilibrium, okay, uplift by water pressure, and hydraulic heave erosions. Okay, so it depends on the situations. Okay, for example, if the structure is located, okay, where the groundwater level is high, so most probably we may consider this situation in the design. Okay. What is the okay? An exception to the application of partial factor is made in relation to water pressure. Okay, it is recognized that the application of partial factor to water pressure can, in some circumstances, lead to unrealistic high water pressure. In this case, it is suggested that suitable margin of safety be applied to characteristic water level. Okay. 3 basic design approach are permitted in assessment of ultimate limit state and are applied according to local practice. Okay, for most simple geotechnical design situation, Okay, the geo limit state will be critical to the sizing of the foundation and structural member. Okay. The section of the code covering specific design issues such as pile foundation and spread footing. They give advice on the limit state that need to be considered. Okay, where groundwater level is present in excavation or cutting, the UPL and HYD limit state need to be considered. Okay. The STR limit state is less well defined, but is nevertheless very important in some design situation. The STR case might become critical where imposed loading cause deformation of some part of the structure or deformation of the ground impose deformation on structure member. For most of the design problem likely to be encountered, the STR and Geo ultimate limit state are the one that we apply as they cover the routine design of shallow and pump foundations and other common geotechnical structure. Okay, so STR and Geo is common to be used. Okay, and also for the EQU is intended to cater for the rare occasion when, for example, a rigid retaining wall bearing on a rigid rock foundation could rotate about one edge of its base. Okay. The UPN and LHDHL, while more common than EQ, are generally beyond the routine. Okay. Okay, so this is the failure condition they consider as an unrealistic possibility. Okay, which is the limit ultimate limit state uh, cases. Okay, then we move to serviceability limit state. Okay, SLS are defined as state that correspond to condition beyond which specified service requirement for structure or structure member are no longer met. Okay, settlement that is excessive for the purpose of the structure. So it is not a technical statement. Okay, it is more related to comfortness of the user. Okay. So for the stability limit state, the limit state that concern the functioning of the structure or structure member under normal use. Okay, this is the comfort of people, the appearance of the construction works. Okay, shall be classified as serviceability limit state, inconvenient, disappointment, and more manageable costs. It should be rare, but it might be uneconomic to eliminate them completely. Okay, so this is example for the serviceability failure. Okay, where they have a crack, excessive settlement, okay, happen at the structure. Okay. Okay, who should carry out geotechnical design? Okay, so part one, provide a useful although optional definition of categories of geotechnical structure. Okay, so they have defined into three category. Okay, for the first category, okay, includes relatively straightforward structure in which routine methods, including prescriptive method, may be used. Okay. So while the code makes no attempt to define level of competency, experienced civil and structural engineers should be capable of preparing the geotechnical design basis for the category 1 structure. Okay, so it means that for GC1, so it's not required for the contractor uh, to follow 100% on the EC7. Okay. So for example, if they want to build what we guard house, okay, or whatever structure is very light structure, you know, no need to have 100% follow 100% on the EC7. Okay, so designer should be capable of judging whether a design station is not more complex than allowed within the geotechnical category. Okay. Structure that involve excavation below the water table but otherwise conventional structure without unusual risk are identified as geotechnical category 2. Okay. Such structure normally require some form of geotechnical characteristic based on field or laboratory testing. Okay, so this is a common type of structure that normally we may construct. Okay, for example, resident normal house. Okay, excavations. Okay, so we should have some understanding on the field and also need to conduct for laboratory testing. Okay. So the term geotechnical engineer, geotechnical specialist, geotechnical advisor are defined. Okay, it was suggested that design work on CG2 structure should be carried out by an experienced civil or structural engineer. Okay, so that is compulsory for the CG2. Okay, and the last one is uh, okay, this is wrong. This is actually GC2, not CG2. Okay, so GC2. Okay. So for the GC3, cover situations that are considered unusual or are associated with high risk. Okay, so GC3 project will typically involve advanced field or laboratory testing and numerical analysis. Okay, the Association of Geotechnical Specialists advocates the role of geotechnical advisor in establishing the design strategy of large project, and it would seem to be appropriate to GC3 structure. Okay, so this is required for a very experienced civil engineer. Okay, should have advisor as well, and should carry out for a very comprehensive field and laboratory testing, and should carry out for a numerical analysis as well. Okay. Okay. So who should decide which is GC1, GC2, GC3? So for me, it's based on the experience. Okay, for the designer. Okay, for example, it's very complicated, so perhaps it can categorize under GC3. Okay. Okay. So this is some example on the equation for ULS. Okay. So we may learn during the example. Okay. So for example, we need to identify what is the, so E is the action effect, okay, while R is the resistance. So we need to make sure that the resistance should greater than the action effect. Okay. So in here we have an action which is described as a load. Okay. Then we have a material properties. Okay, and then we also have a dimension geometry. Okay. So D is the factor that we may apply, okay, on each parameter. Okay. So then based on this first equation, okay, they include, okay, what we call as the representative value, okay, characteristic value, okay, partial factor unit for action with unfavorable deviations, okay, in the equations. Okay, so we may look on the example later, okay, in terms of how the applications of all these factor, okay, in getting the factor safety value. So for the design value of action, okay, design value of action, design value FD of an action F can be expressed in general term, okay, as FD equal to partial factor times with the F representative value, okay. So that is the factor that should be used, okay, in the design. okay, for the action. So normally action we may multiply with the uh, partial factor of safety. Okay. Okay. In more cases, okay. Okay, then we look on the material. Okay, the design value of material of product properties. The design value SD of the material of product property can be expressed in general term as the XD. Okay, where the XK over gamma M. Gamma M is the partial factor of safety for the material or product property to be take account. Okay, where mu is the random part of conversion factor. Okay, normally related to skin effect. Alternatively, okay, in appropriate cases, the conversion factor may be used. Okay, implicitly take, taken into account with the characteristic value or by using the gamma n instead of gamma m. Okay. So then another one is the what we call is the design value for geometrical data. Okay. So normally there is no significant difference on the geometry, okay, to be used, okay, in the design unless we are scaling up or scaling down. Okay, basis of geotechnical design, refer detail on Eurocode general, okay, design requirement, design situation, durability, geotechnical design by calculation, design by prescriptive measure, load test and test on experimental model, observation methods, geotechnical design, a report. So we look on the design approach. Okay, this is uh, generally provide design approach to control the strength of the soil and apply load. Okay, M and R, soil strength such as cohesion, friction angle and density will be reduced using the partial factor. Okay, A, load surcharge will be increased with the partial factor. And for the design approach, okay, we have two type of design approach, which is design approach 1 and design approach 2. Okay, however, for Malaysia case, okay, as we follow the the British or the UK, okay, we only use the design approach 1. Okay, so for the design approach 1, there will be a combinations of 1 and combination of 2. Okay, A1 plus M1 plus R1. And for combination 2, we have here A2 plus M2 and plus R1. Then after the calculation, we may refer to the conventional value. Okay. So this is example of the design approach 1, the factor safety, okay, partial factor safety for the combination 1 and combination 2, and also the design approach 2, okay, where the combination 1, a combination only have one combination, okay, under A1, M1 and R2. Okay. So here we have a unfavorable and favorable for the action. Okay, so this is for the material soil. Okay, and then this is for the split footing for the shallow foundations. Okay, so then there will be a design approach 3. Okay, combination are denoted by A, action, M, soil parameter, and R for resistance. Okay. So it depends if you are looking on bearing, so we may use the R1 under the split foot of for shallow foundation under a bearing. Okay, if you are concerned on sliding, so we may refer the R1 under the sliding. Okay. So Malaysia practice use only design approach 1. for STR and EQU in the design. Okay. So this is the design approach 3. Okay. So but we only discuss on design approach 1 for Malaysia case. Okay. So why? Because we are follow the United Kingdom, okay, UK. So UK only use design approach 1. Okay. Compared to the other country, okay, some country use design approach 2, 3, 1 or 2, 2 or 3, 1 or 2 or 3. So I didn't have the answer why we only use design approach 1. Okay. I guess the only answer is because we are refer the United Kingdom. Okay. Okay, what combination of partial factor of use? Combination 1 involve the consideration of factor, action, and unfactor material property and resistance. Combination 2 consider unfactor action, accept unfavorable variable action and factor material. Difficulty arises with the application of numerical method, such as a finite element in the assessment of ultimate state. Okay. However, now some of the software, okay, they also include the Euro code in the software itself. Okay, so there will be no issue on that on the numerical part. Okay. So in this case, the factoring of soil strength of stiffness can lead to the generation of inappropriate mechanism in analysis. Okay. Uncertainty can also be experienced in assessing slope stability, where it can be difficult to separate favorable and unfavorable action, and in the design anchor, where the design and execution codes provide conflicting advice. However, for Malaysia standard, we doesn't include yet the case for the anchor. Okay. So stability state are usually assessed by adopting unfactor action and material properties. Okay. So in this area, numerical analysis provide a useful tool for GC2 and GC3 projects. So national choice is permitted in the use of design appropriate for STI Geo. Okay, so this is for the Malaysia practice. And as indicated in table NA1, only design approach 1 is to be used in Malaysia. Okay. So then we may refer to the table NA1, okay, in the Malaysia standard, where national choice may be exercised in respect of factor value for design in Malaysia. So they will be slightly different, but I'm not sure in terms of which element that difference between the EN and also the MS. Where choice applies, the table NA1 indicate where value are given or state a value of to be used or prescribed the procedure for specifying factor. Okay, so they have include all the difference between the EN and also the MS, okay, in the table NA1. Okay, so you may refer later, okay, in the page number 2 and page number 3 in the Malaysia standard. Okay, so only design, okay, other than pile or anchor use. Okay, so we may use combination approach 1 for axial load, the pile and anchor. Okay, where M2 is calculating for any unbearable action such as negative spin or transverse load. Okay, refer only to design approach 1 based on Malaysia standard. Okay, so this is a table. I guess it's very useful to be used. Okay, this is for the what we call a shallow foundation. Okay, and also for the deep foundations, retaining wall, okay, slope as well. Okay. Okay, A for action, M for soil property, R for resistance, E for effect. Okay, used for temporary structure or transient design situations such as end of construction stability for embankment when likely consequence justify it. So yeah, this is, has been simplified by Prof. Ramli. So he has put in one table. Okay, so therefore no need for us to refer to the MS standard. Okay, because it's already been provided in one single slide only. Okay, so then we may use in our example later on. Okay, on how to choose the number in this table. Okay, so this is more related to certain situation. Okay, which is I will not discuss in the example, just for a general information. Okay, applying for inverse load. Okay, in design situation where the ground strength act in unfavorable manner, the design value of unfavorable action may be obtained by the following methods. Applying the inverse set of the M2 set of partial action factor to the characteristic unfavorable action. Applying the inverse of M2 set of partial material factor to the characteristic material strength to the obtain the design strength and hence the design unfavorable action. Okay. So recommended value for partial factor safety, negative skin friction. Okay, so this is on the negative friction for the PAR design. Okay, so also we not discuss in the example, just for a general information only. Okay, so then we have a model factor. Okay, this model factor normally be used in the pile design. Okay, we may look later on the example. Okay. So the value factor provided here are considered to be general application for the pile foundation. Okay. So verification of this factor is permitted in particular circumstance when justified by thorough consideration and documented experience and after being agreed where appropriate with the relevant authorities. The factor should be 1.4. Okay, so and then 1.2 is we carry out for a maintain load test. Okay, to calculate factor unlimited. So this is based on experience justification from, but this is based on the true field test. So they apply the model factor. Okay. So design value of action. Here we have characteristic action. Then we need to calculate for the representative action. Then design action, design effect of action. From there we may come up with the value for the factor safety or the difference between ED and RD. Okay. Okay. So that's all for the introduction on the EC7. Okay. So we may continue later on the shallow foundation. Okay. So we should have a rest for 5 minutes before we continue for the second lecture on shallow foundations.